Hello and welcome. Today we're going to be going over converting binary, decimal, and hexadecimal numbers. So first we're going to go over converting binary to decimal. So first let's go over what the makeup of a binary IPv4 address is. So right here you can see all these numbers are in ones and zeros, which is binary. And there's going to be 32 of these ones and zeros. So an IPv4 address is 32 bits long. Then in each of these little sections separated by the dots, these are octets, and there's 8 ones and zeros or bits in each of these octets. Then all these octets make up the IPv4 address, and they all add up to 32. So that's the basic structure of a binary IPv4 address. So next, we're going to go over something super important, which is your powers of 2 table. So this thing's going to be super useful. So you're going to use it for everything in this video, and also subnetting, which is a super important part of networking. So basically, just like math, if we have 2 to the power of 0, we get 1. If we have 2 to the power of 1, we get 2. 2 to the power of 2, we have 4. And then basically and so on. So, using the powers of 2 table, where we can actually convert this super long binary address to decimal, which is what you're used to seeing. So we're going to go over how to do that right now. So as you see, we have little sections here, and we're just going to take each of these octets at a time. So we're going to focus on the yellow circled one right here first. All right, so essentially all we have to do is, we take all these ones and zeros, we just basically transfer it to this table. So we're going to put a 1 here, 0, 1, 0, 0, 1, 0, and a 1. So it's basically that simple. And then basically wherever we have a 1 here, we're going to take that number and we're going to add them all up. So we'll have 128 plus 32 plus 4 plus 1. So, and then basically you can just ignore anywhere there is a 0. So, all these numbers are going to add up to 165. So that takes care of our first octet here. So we're going to write basically it down right here, 165, and have a dot. And now we'll move on to the next octet. So let me erase everything so we can work. So now we're going to move on to this octet. All right, so we're just going to basically do the same thing. So we'll have a 0, 0, 1, 1, 1. Oh, and let me add the 165 down here so we remember. So, and then after the 1, we have 0, 1, and 0. So again, we're just going to add up all these numbers. So 32 plus 16 plus 8 plus 2. And then let's calculate that. 32, 16, 8, 2. That's 58. So now we have 58 down here. And then we just repeat the process for every other octet. So we have 165.58. Now we'll focus on this one. So again, I'm going to transfer the numbers here. We're going to add them all up. So that will give us 199. So we'll place that down here. Then you can see our address is starting to form. Again, let's erase all of our work so we can move on to the next octet. I'll rewrite what we have so far. And then that goes 199. And now we just need to focus on this last octet right here. Again, transfer the numbers. Alright, and then we just got to add them up. Then that will give us 43. Alright. And now we have converted the binary to decimal format. So our final answer is 165.58.199.43. So pretty simple. So also just a quick note about binary. So these two things are actually the same. So one neat thing about binary is you can actually just ignore and omit these zeros. So just keep that in mind. But these two are exactly the same. So that's important to know. All right, now we're going to go over decimal to binary conversion. So again, we have our nice IPv4 address. This time we have numbers though, because it's in decimal format. So just like before, we have octets, and they're each, except this time it's made of decimal numbers. Then there are 4 octets here in an IPv4 address. All right, now we're going to go over how to convert decimal to binary. So again, this powers of 2 table, super important. You need to know it. So we're going to take, just like before, we're going to take each section at a time. So we're going to focus on 165 first. So this time it's a little different. So going from left to right, we need to find the first number that is less than or equal to our number, which is 165. So 128 is less than or equal to 165. So we are going to put a 1 there. Now, we're going to take our number here, 165, and we're going to subtract 128 from it. And then that's going to give us 37. So now using this number, going from left to right, we need to find the first number that is less than or equal to 37. So 64 is not less than or equal to 37, so we're going to put a 0 there. Now, right here, 32 is less than or equal to 37, right here. So we will put a 1 there. Then now we're going to take our 37 right here, and we're going to subtract 32 from it. And then that's going to give us 5. Then using our 5, I'm going to go from left to right, and we need to find the first number that is less than or equal to 5. So 16 is not less than or equal to 5, so we're going to put a 0. 8 is not less than or equal to 5, so we'll put a 0. 4 is, however, less than or equal to 5, so that will be a 1. So then we take our 5 here, and we're going to subtract 4 from that. and that's going to give us 1. And then we take our 1, and going from left to right, we need to find the first number that is less than or equal to 1. So 2 is not less than or equal to 1, so it's a 0. 1 is, however, less than or equal to 1. So we'll put a 1. So then now we have our binary right here in our table. So 1, 0, 1, 0, 0, 1, 0, 1. So, okay, hold on. 1, 0, 1, 0, 0, 1, 0, 1. So let me clear this. Alright, so we'll put our number down here. 1, 0, 1, 0, 0, 1, 0, 1. And we'll put our dot there. That separates it. So now we're going to focus on 58. So we're going to do the same thing from left to right. We need to find the first number that is less than or equal to 58. So 128 is not less than or equal to 58, so that gets a 0. 64 is not less than or equal to 58, so that gets a 0. 32 is, however, less than or equal to 58, so we put a 1 there. Then we'll take our 58, and we're going to subtract 32 from that. So that's going to give us 26. So then now that's going to be our new number. So going from left to right, we need to find the first number that is less than or equal to 26. So 16 is less than or equal to 26. So we'll put a 1 there. Then we'll do 26 minus 16, which will give us 10. So then we'll take our 10. We need to find the first number less than or equal to 10, which is 8. So then we will do 10 minus 8, which gives us 2. So that's our new number. We need to find the first number less than or equal to 2. So 4 is not less than or equal to 2. So that gets a 0. 2 is, however, less than or equal to 2. So that gets a 1. So then we'll do 2 minus 2, that equals 0. So new number, again, so 1 is not less than or equal to 0, so that gets a 0. So then our final answer is, for the octet is 0, 0, 1, 1, 1, 0, 1, 0. Alright, so let's clear everything. So I'll add it down here. 1, so 0, 0, 1, 1, 0, 1, 0. And then we'll separate it. So now we'll focus on this number right here. Alright. So, taking this number, we need to find the first number going from left to right that is less than or equal to 199. So, right here, 128 is less than or equal to 199. So we'll do 199 subtracted by 28. That will give us 71. Same thing, that's our new number. And then 64 is less than or equal to 71. So that gets a 1. So 71, take away 64. going to be 7. That's our new number. So 32 is greater than, so 0. 16 greater than. 8 is greater than. So 4 is our next number. So then we'll do 7 minus 4. And then that gives us 3. Then same thing. So 2. So that's our new number. 2 is less than 3 or equal to 3. So I could say 1. And then we'll do 3 minus 2 equals 1. New number. And then 1 is less than or equal to 1. So that gets a 1. So then for that octet, we have 1 1 0 0 0 1 1 1. Oh, let's clear everything so we can work on the next octet. All right. So 1 1 0 0 1 1 1. And now we go on to 43. This is our final octet that we have to do. So again, we do the same thing. So 128 is greater than 43, so that's a 0. 64 is a 0. 32, though, works. Then we'll do 43 minus 32. Yeah, and that gives us 11. So then we'll take our number 11, so 16 is greater than 11, so that's a 0. 8, though, is less than 11, so that's a 1. We'll do 11, take away 8. That gives us 3. So then that's our new number. So 4 is greater than 3, so that's a 0. 2 is less than 3, so that's a 1. And 3 minus 2 equals 1. And then right here, 1 is equal to 1, so that's a 1. So then that finishes off that octet. So 1 0 1 1. Okay, so final answer is 1 0 1 0 0 1 0 1 0 0 1 1 0 1 0 1 1 0 0 1 1 1 0 0 1 0 1 0 1 1. That's how you convert decimal to binary. It's a little more tedious, but still fairly simple. All right, so now we're going to go over an IPv6 address. So right here is an IPv6 address here. So IPv6 addresses are in hexadecimal format. So we have both numbers here, and we also have letters, which are new. All right, so each of these little sections are an octet, and they again have numbers and letters within them. So there's some cool rules to IPv6 addresses. So this is a super long thing to have to be typing out. So there's some little tricks we can use to actually shorten this and make it easier to deal with. So first off, look at all this. That is super long and there's tons of zeros there. But this is all unnecessary. So look what we can do. We can just remove all that. And then we're just going to slide that over. And then we just add in 2 colons there. So you just put these 2 in there, and that signifies that there was a series of zeros. Now, there's one really important rule. This can only be used one time. All right, so we shortened this, but there's still more we can do. So how can we address this issue right here? We got a couple zeros there. Well, we can actually shorten that by just replacing it with a single zero. That will let you know that that whole octet is filled with zeros. But we can just write it as having 1 0. But there is more we can do. So we can get rid of more zeros and do this by omitting leading zeros. So we have one leading zero right there, and we have another leading zero right there. So again, we're just going to remove those. And then now we have our final result. So we have our super short address now, which is much better and easier to type in than the long one from before. So those are some tricks to make IPv6 addresses a little more bearable to use. All right, time to go over hexadecimal to decimal conversions. All right, so again, we're back to our powers of 2 right here, except this time it's a little less. So we just need to remember these magic numbers. So we have 1, 2, 4, and 8. And that's all we're going to need for today. All right. So one thing about this, as you can notice, we only have like 2 digits here. Well, normally you would have 4 in an octet. So in my Cisco class, we only dealt with 2 digits. It's possible to go more. It just makes it a lot more cumbersome when we're converting. So for now, we're just going to deal with 2. That's all you should have to know, basically. At least that was for my Cisco class. That's all we had to know. All right. So here's what we're going to do. So we'll deal with 3 first. Again, we're going to split these up, kind of make it easier to work with. So basically, we need to find numbers down here that will add up to 3. So 8 is not going to be one of those numbers. So we'll put a 0 there. 4 won't be one of those, so we'll put a 0 there. But 2 is. That will work. And then 1 will also work. So those both add up to 3. So now we're going to focus on E. So this is not a number, so how are we going to have these add up to each other? Well, so basically the way hexadecimal work is these go letters correspond to numbers 10 and above. So all numbers 1 through 9 will just be written out like this. But when we go above 9, like say we have 10 or 11, 12, 13, all those numbers that have 2 digits in them, we actually will be using a letter. So basically, I'll write these out kind of. So A is equal to 10, B is equal to 11, C is equal to 12, D is equal to 13, E is equal to 14, and then F is equal to 15. Now hexadecimal only goes up to F, so we will stop at 15. There are no numbers that will be no numbers above 15 in hexadecimal. So F will be your I guess highest letter. You'll stop at F. You don't go past F in the alphabet. So we know our letter here is E. So we're going to find E, which is right here, and that corresponds to 14. So we need to find the numbers down here that will add up to 14. So we'll use 8, and then we're also going to use 4 here. And then, but we're still missing a couple numbers. So we'll have to use the 2. That will bring us up to 14. So we don't need to use the 1. So we can put a 0 there. And then now we have our final binary format. So if you just need to convert from hexadecimal to binary, you can stop right here. This is your final answer. But we're going to actually take this number and convert it to decimal format. So again, here's our our binary number that we solved on the previous slide. And then guess what? We have our nice power of 2 table back here again. You'll never escape from this. It will be here forever. So, as before, you can probably already guess what we need to do. So we're going to fill in these numbers here. 1, 1, 1, 1, 1, and 0. And then again, we just need to add these up. 32 plus 16 plus 8 plus 4 plus 2. And what does that equal? 32 plus 16 plus 8 plus 4 plus 2. That is 62. So so we successfully just converted from hexadecimal to decimal right here. So not too difficult. All right, now we're going to go over how to convert from decimal to hexadecimal. All right, so our number will be 62. So that's our decimal number that we need to convert to hexadecimal. So first we actually have to convert that to binary. So just like before, we have our nice powers of 2 table. Can't escape it again. So we're going to we need to select numbers here that will add up to 62. So 128 won't be that. This won't work. 32 will work though. 16 will work. So then 32 plus 16, that gives us 48. So then we'll add on another 8 to that. So that gives us 56. Add on to another 4. So that will give us 60. And then now we'll add a 2, and then that will get us to 62. So then we don't need this 1, so we're just going to put a 0 there. So we've converted from 62 to our binary format. All right. So now that we have our binary format, we can convert to our hexadecimal. So we're going to do the same thing. We have our magic numbers 1, 2, 4, 8, all in our nice little thing here. I would lay it out like this, makes it nice and easy. So we're just going to fill in the numbers. So 0, 0, 1, 1, 1, 1, 1, 0. So again, these are going to add up to 3. And then all this is going to add up to 14. So again, the kind of cool thing about hexadecimal is that normal numbers 1 through 9 are just written as their digit. And then anything 10 through 15 is written as a letter. So let's clear all this. What is 14? So again, A is going to be 10, B going to be 11, C going to be 12, E is going to be 13, F is going to be 14. Wait. Oh, no. I don't know how to do the alphabet. So E is going to be, a D is going to be 13. I missed D there. E is going to be 14, and then F is 15. So this is the letter we need. So 14 is going to be E. So our final answer is going to be 3E. Right there. So pretty simple. Just remember your alphabet, unlike me. All right. So that ends our converting numbers video here. So next video, which should be on your screen right now if you're watching this on YouTube, is subnetting. So using the knowledge that you've learned here, we're now going to move on to subnetting, which is basically splitting up IPv4 addresses into smaller uh, uh, kind of groups. So you'll get to use your magical power of 2 table again. So again, you're not escaping it. But check out that video. Goodbye.